All right, so now let's start analyzing these microcoded machines that have these instruction set interpreters in it. This is a picture of John Koch. He's the 4th person to win the Turing Award from an architecture. The thing that changed around 1980s was that we switched from everything was done, well, not important stuff or low-level stuff was an assembly language to you could do it in high-level languages. So maybe the turning point was Unix. This is an operating system that was written in a high-level language, but before that they were all written in assembly language. So that meant it wasn't what assembly language programmers could do, it meant what the output of the compiler was what the architects had to deal with. And so John Koch and his group at IBM, besides doing architecture work, they were very good at compilers and were advancing it, and they had built some experimental compilers. They had this idea that why don't they try for this IBM architecture before, let's just use the simple instructions. Suppose we just use the loads and stores and register to register. Let's not use the complicated ones. I wonder what would happen. So what happened when they did that is it ran 3 times faster than if you used the whole instruction set. So that's a surprising result. So then some people at DEC did a study about looking at the microcode there, the VAX architecture that I mentioned earlier, and they found that the flagship, the first one, averaged 10 clock cycles per instruction. So it took 10 micro-instructions to execute instruction on average. And that was a much bigger number than they thought. And that they also found that the microcode, that 20% of the instructions used 60% of the microcode, and it was almost never used. So that kind of calls into question. I was involved at a sabbatical at DEC to help with microcode bugs, and I came away impressed with just how hard it was to get the bugs out of the microcode. And if what I expected to happen is microprocessor companies would copy the mini computer companies and have very complicated instruction sets, I came back and wrote a paper that said, if you're going to do that, you have to have repairable microcode. And I was going to do it with writable control store. And so I come back from my sabbatical, write a paper, I'm an expert, right? And the paper, I submitted IEEE computer, and they rejected it. And what I remember the reviewers saying is, this is a stupid way to design microprocessors. So I had this thing in my head, well, if the instruction sets get more complicated, you're going to have to repair it, and having to repair a microprocessor is a stupid idea. So this, got me thinking.